All right. I want to take this last video to dive a little bit deeper into some questions that you may have coming out of the chapter. This is an optional video, but it's going to help to unpack both the decision about statistical significance as well as how our data may be affected by the power of our study. So again, this is a bonus video, but you may want to watch it in case you're having a difficult time understanding some of the issues or the problems that we've talked about from the previous study. So first of all, what is the statistical significance decision? First thing we should know is the question is not, is there a difference? That's not what statistical significance is answering. The question instead is the difference bigger than we'd expect if only random factors were at work? So the decision to declare that a difference is not due to chance. Can we safely declare that the difference between our experimental group and our control group here on listening skills is not due to chance, or is bigger than that we would expect by chance? So the results here are the difference between two means. The difference here between those exposed to an angry student and those exposed to a non-angry student. But to just compare the means is insufficient. We need more. What we need to say that this difference is not due to chance is we need statistically significant results. What statistical significance tells us, and remember, statistical significance we declare when our p is less than 0.05 most times. Every once in a while you may want to use a more stringent p, but typically p is less than 0.05. What that means is that we're sure beyond a reasonable doubt that differences are not due to chance alone. So we're sure beyond a reasonable doubt that it's not due to chance alone. There may be some of these differences that are due to chance, but it's not only chance. That at least some of the difference was likely due to the treatment. So those are statistically significant results. What do non-significant results tell us? Well, we actually can't reject the null hypothesis. In other words, it's possible that the results were due to chance. When we have non-significant results, it means we can't reject that bummer of a friend that says there's nothing going on here. We have to retain that. We don't prove it. We just can't reject that friend. We can't prove him or her wrong. So significantly different, let's see. These statistically significant results are not necessarily large. So for instance, we could have a really large sample size in our study. In that case, even a tiny little difference between our variables can be significant. So we saw that actually a little bit in our study results. When we compared all the men and the women across the conditions to one another, in other words, we had a large N where we were comparing all the angry to all the non-angry groups. What we found was even a small difference in their listening skills turned out to be significant. However, when we had a small sample size of women, only 8 in one group and 7 in the other, what we found was even a big difference between genders didn't result in significant results. Second, so first, statistically significant effects are not necessarily large. Second, they're not necessarily important. For instance, if you design your experiment poorly, you could have all the statistical significance in the world and your results don't mean anything. Next, statistically significant results may not be in the direction that you expect. You could have a p-value of less than 0.05, but it may be the case that your treatment affects your subjects in the opposite direction. Like here, if we found that people in the angry group actually listen better than those in the other groups. Okay, and the last point here about significant and non-significant results is the issue of why it is that we can't draw conclusions from our non-significant results. So non-significant results are not significant. In other words, even if there's a visible difference between groups, if one group scores 90%, the other group scores 70%, we can't use the data to claim that it's there, that that difference is real. However, and this is important with respect to the study that we just went through, null results, meaning no significant difference between groups, null results don't prove the null hypothesis. In other words, I didn't find it doesn't mean it doesn't exist. When our p is bigger than 0.05, non-significant p, that means I didn't find a difference. That does not mean that the difference doesn't exist. There's a parallel to this. Imagine trying to, for instance, prove to me that your skin cells are different from your neighbor's skin cells. Now, we know, based on at least the theory of DNA and decades and decades of research and data points, that your skin cells, every one of your skin cells, is different from every one of every other person in the world's skin cells. But you may have a difficult time proving that to me because you lack the measurement ability. In other words, you may have null results. You can't find a difference. Just because you can't see a difference between the difference in your skin cells doesn't mean that they're not different. Okay, so the last thing that I want to talk about has to do with power and how random error can actually affect groups. So we talked about power before. We talked about how we can reduce the effect of random error by standardizing our procedures, using more homogeneous groups, and coding data. We also talked about how we can affect power by letting error balance out and causing larger effects. So this one is increasing your sample size, and this is increasing the difference between groups. So I want to spend just a couple minutes taking a look at what that may actually look like if we look at it visually. Okay. So what we know is that random error, all those little differences between every person, makes scores within a group differ. In other words, even if you have 150 people who all come face to face with an angry student, their listening skills are going to differ. Some people are going to listen really well. Some are going to listen really poorly, even though they're faced with the exact same level of anger. What's also true, though, is that those same differences between individuals can also make our group means different. Why is that? Well, because let's say you have group 1 and group 2. In group 1, let's say you have someone with low listening skills, someone with high listening skills, and someone with exceptionally high listening skills. In group 2, you have someone with low listening skills, with high listening skills, and someone with kind of high listening skills. They've been randomly assigned. And let's say then they get different levels of the treatment. One gets an angry person, one gets a non-angry. Well, this person is likely to listen better than this person is, even under angry conditions. So when you average all these people together, you're likely to get higher listening skill than when you average all of these people together. A less high. In other words, these people on average have quite high. These people on average have kind of high. This isn't due to what you've done to them. It's due to their pre-existing listening skills. Okay, so random error can make the group means differ. So when is a difference too big to be due to random chance alone? In other words, when is a difference significant? Well, too big to be due to chance depends on a couple different things. It depends on how big chance is. In other words, the differences within a group, how much people differ, for instance, in their pre-existing listening skills, can tell you how much those listening skills are operating on chance. and too big to be due to chance depends on how much chance balance out. Remember, with larger samples,